Jai Hind everyone. Myself Mrignainy Kansal, the assistant professor in the IT department, will going to discuss about the software evolution and the maintenance. Today we will going to be discussing about how the software evolution and the maintenance is a very important phase in a software engineering, in the software development complete process. So what are the outlines we will going to be cover in this session? That first of all we will going to cover, that is the evolution versus the maintenance. In the sub part of the evolution versus maintenance is the software evolution and the software maintenance. The software evolution models and their processes, the re-engineering and the legacy system, impact analysis, refactoring and program comprehension. Lastly, we will going to be discuss about the software reuse. Now, what is the actually difference between the evaluation and the maintenance? Why we are discussing about, at the initial phase, we are discussing about the evolution of the software, that how the software will going to develop, how the processes will going to be make up. Like, later on, we are end up with the maintenance phase, which will be the never ending process. So, what is the difference between both of these terminology, that is the evolution versus the maintenance? The term evolution and the maintenance, however, there is a semantic difference between them. The Lowell, J. Arthur distinguish the two terms with the help of their definition given by them. Software maintenance and the software evolution. Software maintenance means to preserve from the failure to the decline. This is the maintenance phase where we are trying to preserve the failure to the decline. If the failure will come, the fault will occur in a software, we are making them preserve that it should not be reached to the decline phase, that we need to be dump that software. We are not reaching to that phase of the software. Whereas the software evolution means a continuous change from the lesser, simpler or the worse statement of a higher and a better state. That is known as a software evolution. That means we are continuously doing the processes and making the software in such a way that it can be easily, that it can be simplified, used by the user. The user is comfortable to make them use. That is the state which will be going to be done in a software evolution. Whereas the Keith H. Bennett and the Lee Zhu use the term maintenance for their post-delivery support, and also the evolution will be given by the change in the requirement. That means the changes will become in a requirement that will be give a evolution of the next version of software, whereas the maintenance will be the continuous process of making the software not reaching to the decline state, make them usable by the user as per the requirement given by them. Now, the maintenance is considered to be set of plant activity, whereas the evolution concerned whatever happened to a system over the time. It is a set of the plant activity. The plant activity are already fixed and we need to be make them correct so that it should not fail at the end. Whereas the evolution means whatever happened into the system over the time, and we need to be make the changes as per the requirement of the environment. So the evolution of the next one version will be going to generated by the help of the software evolution. The Mehdi Zaser view a software evolution, that is, over time what evolve is not the software but over knowledge about the particular type of software. The over time we are not actually evolving the software. On the basis of the knowledge, the changes we will going to be cover up is known the reach of the evolution of a software. So in 1965, the Mark Halperin used the term evolution to define the dynamic growth of the software, where the term evolution is relation to the application system to the gradually in the 1970s, whereas the Lehman and his collaborators from the IBM are generally credited with the pioneering the research field of the software evolution. The Lehman formulated the set of observation that he is called the law of evolution. These laws are the result of studies of the evolution of the large scale, not on the smaller scale. They are actually evaluating or evaluating the software, their evolution on the large scale it to be happened. The law concerned what Lehman called E-type system. The monolithic system produced by a term within the team, within an organization that solve a real world problem and have a human use. That is the law which is given by the Lehman. The software evolution, given the certain terms which is explained by the layman as a law of the layman for the software evolution to be explained. So, continuing changing, first of all, a system will become a progressive, less satisfying to its user over the time unless the continual adopted of meeting the new needs. We are trying to progressively less satisfying the user if they are actually continuing changing their requirement as per their attraction or as per their interaction or as per their satisfaction toward their system or their software. Increasing the complexity. Secondly, if the complexity increases, the system will become progressively more complex unless the work is done explicitly reduce the complexity. Self-regulation, that means the process of software evolution is self-regulating with respect to the distribution of the product and process artifacts that are produced. Conservation of the organization stability. The average effective global activity rate on the basis of evaluating the evolution of the software. It does not evaluate it on the basis of the over the time. That is the average amount of the work that goes into the each release. That will be the above case in this. So these are some of the laws. The 4 laws here it is explained. In the next slide we will going to be understand that what are the other laws given by the layman. The 5th one, that is the conservation of the familiarity. That means the amount of new content in the each successive release of the system tend to stay constant and decrease over the time. That will be decreased. At the each iteration, the amount of changes to be done get decreases because continuously we are actually doing the effort in the evolution of the new software. Evolution in the software will reach the customer to their satisfaction. Continuing growth, the amount of functionality in a system will increase over the time in order to please its user. Declining the quality, a system will be perceived as losing the quality over the time unless it design it carefully and new constraint will become as per the time move on further. Lastly, the feedback system. The feedback will help the developer to understand the actual requirement of the user. The user when interacted with the system will provide their feedback that what actually they are getting from this. So successfully evolving a software system requires recognition that the development process is a multi-loop, multi-agent, multi-level feedback system. That means at every successive level, every level we are getting the feedback from the customer and get to know that actually what they are want, what they are actually require from the system. Now the evolution on the basis of FOSS system, that in the CRISA 1988, the pointed out the difference between the evolution and the Unix of OS and the system studied by the layman. What is the difference between the laws which is given by the layman as well as the Unix OS which is currently used in the market. So they are arguing the difference in the academic and the industrial software development could lead to the difference in the evolution pattern, that how it is evolving. The circa 2000 empirically studies of the free and open source software evolution was conducted by the Godfrey and the Chu. They found the growth tend to be 1994 to 1999 and for the evolution of the post Linux OS to be the superliner that is greater than the liner. The Robles and his collaborator concluded that the layman laws of 3, 4 and 5 are not fitted to the large scale force system as like the Linux. So the FOSS is made available for the general public with either to be the relaxed and the non-existence intelligent about the property of restriction and free emphasis the freedom and the redistribution over the term of the original license, while the open emphasis and the accessibility of the source code. This is the providing of the definition of FOSS. Now, we have discussed layman laws and the FOSS criteria or the point of view about the software evolution. Now we come out with the topic that is the software maintenance. There will always be defect in the delivery software application because the software defect removal and quality control are not actually the perfect personality to be done in the previous state of your software development process. So therefore, the software maintenance is need to be repaired and these defect in the released software. So E. Burton, Swensson define the three different type of the software maintenance on the basis of corrective, adaptive and the perfective way they are defining the software. It is based on the intent of the developer toward the system. This is the software maintenance. The Swensson definition was later updated in the standard of the software engineering, that is ISO, introduced a fourth category which is known as the preventive. And some researchers and the developer view perspective as a subset of the perfective maintenance. This is done by the help of the software maintenance. The Kitchenham described the maintenance modification in a hierarchical way based on the concept of activity. Activity to be make the correction of there are the discrepancies between the expected behavior of the system and the actual behavior. Then some of the activities are performed in eliminating or reducing the discrepancies. So the activity to make them enhancement, a number of activities are performed to implement a change to the system. So thereby changing the behavior, implementation of the software to be done. So there are some of the subcat division of these three parts on the basis of enhancement, that change exists the requirement, on the basis of enhancement that add the new system requirement, and on the basis of enhancement that change the implementation but not the requirement. So these are the three subdivision of the category which is explained in the software maintenance. Now we will going to be define the maintenance on the basis of the costs. The major difference between the component based software system and the customer built software system are on the basis of skill of the system maintenance team, on the basis of infrastructure and organization, cost maintenance cost, larger user community, motorization, split maintenance function and more complexity. Now the software evolution model, the second topic we will going to divert, that what are the model which is used for the software evolution. So first of all we will going to be use the software maintenance of their own by the help of the software maintenance lifecycle model. So there are three different and popular models, that is the staged model of maintenance and evolution. Next is the iterative model and the last one is the change mini cycle model. So these are the three different models will going to be used for the software maintenance lifecycle. Software maintenance standard, that is IEEE and the ISO, have both addressed the software maintenance process. The IEEE EIA 1219, the ISO as a part of the ISO IEC 12207. These are the recycle process to be performed. So the IEEE EIA organized the maintenance process in 7 different phases. What are those? The problem identification, analysis, designing, maintenance, system testing, acceptance testing and the delivery. So ISO describes the software maintenance as the iterative process for managing and executing the software maintenance activity. So the activity which comprises the maintenance process are the process implementation, problem, modification, analysis, modification of implementation, maintenance of the review and the retirement. So each of these activities are come under the task of the maintenance. Now the next is the software configuration management. As we know, the configuration is a discipline of managing and controlling the changes of the evolution of the software system. It ensures that the release of the software is not contaminated or by uncontrolled or unapproved changes. So the software configuration management system has 4 different elements. Identify the software configuration, control the configuration, audit the software configuration and finally accounting them the software configuration. What are the different changes to be accommodated in a software as per the evolution come. Now the next topic we will going to cover, that is the reengineering. What reengineering is? Till date, we discussing about the software engineering, but still now we are not at the phase what reengineering, the reverse of the complete software engineering is known as the reengineering. How it will going to be better as compared to the software engineering? What are the requirements? Why the terminology come in a market to get advantage of this? So the reengineering is done to transform an existing lesser or simpler system into a new better system. It will reach to the better system. So reengineering is the examination analysis and reconstructing of an existing software system to reconstitute it in a new form, and subsequent implementation of the new different form, that is known as the reengineering. So the Cheskyosy and the Cross 2 define the reengineering as the examination and the alteration of the subject system to reconstitute in a new form and subsequent implementation of the new form, that is known as the definition given by the Chesky and Cross 2, that what the reengineering is. So Jacobson and the Lindstrom define the formula of the reengineering. That means the reverse engineering plus the forward engineering will make a re-engineering. What the reverse engineering is the activity of defining more abstract and easier to understand representation of the system. The core of the reverse engineering is the process of examination, not a process of change. Therefore, it does not involve the changes of the software under the examination. So the third element, that is the forward engineering. What is that? It is a traditional process of moving to the higher level abstraction. That means the traditional way, the way of we are performing the software engineering with the help of the SDLC cycle. So that will be given by this designer or the physical implementation of the complete system. So the second element capture the alteration of the changes of the system, and this is within the complete definition of the reengineering. That means the reverse engineering and the forward engineering. Now the legacy system. What the legacy system defined while we are discussing about the maintenance or the reengineering. So the legacy system is an old system which is valuable for the company, with often the developer and owns it. It is a phase out stage of the software evolution model of the Ridgelet and the Bennett described earlier. The Bennett used the following definition, that large software system that we do not know how to cope with, but that are vital of our organization, that is known as the legacy system, the old system of our company. Similarly, the Brockty and the Stonebaker define a legacy system as any information system that significantly resists the modification of the evolution to meet the new consistently changed business requirement, that is known as the definition given by the legacy system. There are number of options available to maintain or to manage the legacy system. Typically solution given by these. What are those? First is a freeze, outsource, carry on, maintenance, discard and redevelop, wrap and the migrate. So these are some of the options available for to manage the legacy system, the old system of our company, and to manage them and to maintain them over future. So freeze, the organization decide no further work on the legacy system should be performed. Outsource, an organization may decide that supporting software is not the core business and not, or may outsource it to the specialist organization offering this service. Despite of all the problems and support that the decision to carry the maintenance for another period. Discard and redevelop, throw all the software away and redevelop the application once again from the scratch. The wrap, it is the outbox of modernization techniques surrounded the legacy system with the software layout, layers and hidden the unwanted complexity of existing data. Individually, the program will come into the maintenance phase and interact with the new requirement. Migrate, that the legacy system migration basically move an existing operational system to a new platform to make it in a new way to manage them and to run them by the user. So retaining the legacy system functionality and causing the minimal disruption to the existing operational businesses and the environment as much as possible. What are the different impact analysis over the doing the maintenance of a software? So impact analysis is a task of eliminating the part of the software that is affected by the proposed change requesting is made. So impact analysis technique can be partitioning into two different classes. First of all, the traceability analysis, and second is the dependency, how they are actually depending on two different classes. So the traceability. In this approach, the high level artifacts such as requirement, design, code and test cases related to the feature to be changed and identify the model on the inter-artifact, such as each artifact is one level link to other artifact, and it constructed with the help of the locate of the piece of design of code, test and maintain them. Dependency analysis attempt to assess the effect of change on the semantic dependencies between program entities. This is achieved by identifying the semantic dependency that may signal the presence of such semantic dependency. So there are two different dependency based impact analysis technique: call graph based analysis and the dependency graph based analysis. These are the two different dependencies to be there. Two additional notation related to the impact analysis are very common among the practitioner. What is the effect are those? Ripple effect and the change propagation. What is the ripple effect? It analyzes the measure of that how likely to be changed a particular module and may cause the problem in the rest of the program. How, if I am changing one module, then how it will going to be change or affect the complete system or complete program. So measuring of this ripple effect can provide the knowledge about the system as a whole through the help of the evolution. How much its complexity has increased and decreases on the basis of the previous version. How the complex individual part of a system are in the relation to the other part of the system. And it also took effect of the new modules based on the complexity system as a whole when it is going to be added. The change propagation activity ensuring that the change made in one component propagate properly throughout the entire system, that is known as the change propagation effect. Now the next terminology that is known as the refactoring. Refactoring is the process of making a change to the internal structure of the software to make it easier to understandable, to cheaper for the whole change to be without changing any behavior or the operation observable behavior of the system. Then we perform the changes internally. It is the object oriented evaluant and the restructuring. Refactoring, which aims to improve the internal structure of a code through the help of the removal of duplicate code. Simplification, making code easier to understand, help to find the defect and adding it to the flexibility. There are two different aspects of the above definition, that it must preserve the observable behavior of the software system and it also improve the internal structure of the system software. So these are the two different aspects to be recognized by the help of refactoring. Next is the program comprehension. Program understanding and the comprehension is a task of building the mental model and underlying the software system for the various abstract level, ranging them for the model of a code itself, one of the underlying application domain for the software maintenance, evolution and the re-engineering to be performed. So a mental model describe a programmer mental representation of a program to be comprehensive. The mental state at which state will going to be programmer will code the complete program. So the program comprehension deal with the consecutive process involved in constructing a mental model of the program. A common element of such consecutive model is generative hypothesis and investigate that whether they are holding this or rejecting this. Hypotheses are the way to understand the code in the incremental way. After some understanding of the code, the programmer form a hypothesis and verifying it to reading code. By continuing the formulated of new hypotheses and verifying them, the programmer understands more and more code in the form of increasing way. Several different strategies to be performed while doing the hypothesis, that is with the help of bottom up, starting from the code, top down, starting from the high level goal, and the opportunistic combination of the two different approaches. So the strategy is formulated by identifying the action of achieving a goal. These strategies guide into namely as two, that is the chunking and the cross referring, to produce the high level abstraction structuring. So the chunking create the new high level abstract and the cross referring means able to make the link element of the different abstraction level. So chunking and cross referring help in building a mental model of program under study in a different level of making. Last one, the topic we will going to be discuss that how the software will going to reuse them. Software reuse was introduced by the Doc Maclay, is in his 1968 seminal paper. So the development of an industry and reusable source code of a software component and the industrialization production of application software from the off-the-shelf component. So other significantly use reusable by the help of the program familiars and the domain analysis. Program families, that is a set of programs that whose common properties are so extensive that it become advantageous for the study of the common properties as these programs before the analyzing an individual difference. Whereas the domain analysis is an activity of identifying the object and operations of a class of similar system in a particular problem and the domain. This reuse is using to existing the artifact of the software knowledge during the reconstruction of the new different software. This reusability, that means a common code, source code can be easily used for the another program to be developed, which will reduce the time of developers, reduce the cost and easy deliver to the user. So Capus-Jones identify the 4 different usable artifacts, that is a data reuse, artifactual reuse, design reuse and a program reuse. So involving the standardization of the data format, which consists the artifactual reuse, which consists of standardizing a set of design and programming conventional dealing with the logical organization. Design reuse for some of the common business application, and program reuse, which deal with reusing the executable code. So the software reuse of previously code is a way to increase the software development productivity and the quality of the software. So the cost of saving during the maintenance of the consequences of reusing the newly twice are corresponding saving during the development. So the reusability is a property of the software assist that indicate the degree to which it can be reused. For software components to be reused, it must exhibit the following characteristics that directly encourage it to use the similar situation: the environmental independency, the high cohesion, low coupling, adaptability, understandability, and the reusability, portability. So these are the terminology will going to be used for the reuse of the complete software at that time.